Phosphorus can exist in several different forms, which are known as allotropes. Unlike other elements, phosphorus doesn't like to exist as free atoms, so it makes different structures, and depending on which structure it makes with itself, you get the different types of phosphorus. The photos I have for the structures of phosphorus aren't the greatest, but I hope from them you can see that there is a difference. The common forms are white and red, and violet and black phosphorus are much rarer. In this video, we're focusing on the white allotrope, and it's really the most dangerous of them all. Most of the other ones are pretty stable under air, and they're not very toxic actually. Whereas white phosphorus is quite toxic and ignites spontaneously under air. The big thing that white phosphorus does to you if you're exposed a lot to it is it gives you something called phossy jaw. The white phosphorus accumulates in your jaw, and as you'll see later in this video, white phosphorus glows in the dark, so if you get enough, your jaw could actually glow. While that can be cool, it also causes necrosis of the jaw and the surrounding tissue, which is less fun. The major controversial use of white phosphorus, which gets it into the news sometimes, is its use as an incendiary weapon. First, I get a sample of white phosphorus, which is safely stored under a little bit of water. And then to remove a small piece, I use my knife. When I start to cut it, it looks like it's soft, but suddenly it cracks and pieces fly everywhere. From all of the shattered pieces of phosphorus, you can see white fumes of phosphorus pentoxide coming off. The phosphorus pentoxide forms when the white phosphorus reacts with oxygen in the air. Phosphorus pentoxide itself is dangerous because when it comes into contact with water, it forms phosphoric acid. Normally when white phosphorus is exposed to light, it actually becomes a yellow color. It's pretty easy to see that my white phosphorus is actually reddish orange and not yellow. I assume my white phosphorus is discolored like this because it's extremely old. Anyway, now for the fun part of lighting it on fire. Using a barbecue lighter, I light it on fire and you can see that it quickly gets going. To put it out, I simply place another crystallizing dish on top to cut out its oxygen supply. And now to show you the scary part of white phosphorus. You see right when the crystallizing dish is removed, immediately it starts burning again. This is because it can spontaneously ignite at temperatures as low as 30 degrees Celsius. So you can imagine how hard it is to extinguish any white phosphorus if you ever were to get any on you. To extinguish it, I put a little bit of water in, so when the crystallizing dish is removed, it will immediately be covered. So you can see that it's successful, and when it's removed, there's no burning white phosphorus. And now I pour out the water to expose the wet white phosphorus below. You can see that immediately when it's not under water, it starts to fume again. This is from a second run, but you can see that just after several minutes of sitting out, it's fuming a lot. And eventually it will heat up enough to spontaneously ignite itself. So you can see what makes white phosphorus so scary. If you get it on you, you can't just extinguish it, you actually have to completely get rid of it. And then also, as I mentioned earlier, the phosphorus is poisonous, so even when it's extinguished, it's still going to be leaching into your body. I apologize for this shot being a little unfocused, but the point of it is still pretty clear. When the phosphorus burns, it lets off a lot of smoke, which makes sense why it's often used to make smoke screens. This is just to show that it can be a little hard to put out the phosphorus, and you see that I spray it with a little bit of water from the hose, and it causes burning phosphorus to splash everywhere. If the fire was much larger and there was a lot more phosphorus, you can see how spraying it like that could actually just spread it more. As a final test, I place a small amount of white phosphorus on a piece of meat. And then just like before, we light it on fire and let it burn. And then to extinguish it, I put a crystallizing dish on top just like before. And then I take it away to see that again, just like when it was on the glass, it reignites. I let it burn for a while, but it was producing a lot of smoke and I was worried that somebody would call the police. I extinguished the phosphorus and removed it, and there was still a lot left that hadn't burned. The white phosphorus burned for about a minute and it burned away about a fifth of the thickness of the meat. I don't show it here, but the underside of the pork, even after a minute, was still uncooked. I don't have any real conclusions to draw from this experiment, but I was honestly surprised because I thought the white phosphorus was going to do a lot more damage. And this is just a final demonstration to show how white phosphorus exhibits chemiluminescence. When exposed to moist air, the white phosphorus is oxidized and it lets off a very faint green glow. In person, it's actually pretty distinct, but on camera, it was very hard to pick up. So that about wraps up everything I had to show about white phosphorus. Unfortunately, I didn't have any carbon disulfide that I could use to show the solubility of the white phosphorus, but if there's anything else that I missed or that you'd like to see, leave a comment below. Also, if there's anything else that you would like to see in general, also leave a comment and I'll try to get to it. And just for the meantime, above is a list of the stuff that I'm either currently working on or have completed filming and just need to edit. So those videos will be uploaded eventually.